Room is full, so I'm going to get started. My name's Jolyon Bloomfield. I'm from Anthropic, and today I want to kind of give you an overview of the AI ecosystem as Anthropic sees it, and hopefully we'll have some fun in the process. This is basically the ecosystem I'm going to try and cover. It's a little bit ambitious, but hopefully we'll have time to get through it all. I want to start by talking a bit about Anthropic. Anthropic is an AI company. We were founded not very long ago. We've grown very fast. We're headquartered in San Francisco, and our mission, the entire reason our company was founded, was to ensure the world safely makes the transition through transformative AI. When I say this is our mission, I'm not kidding. Like, everything we do is in support of this. We are trying to build frontier AI systems. We're trying to deploy them safely. We're trying to understand how they work, and we're trying to share our safety insights to make sure that AI doesn't go Skynet, or, you know, maybe less traumatic things. Maybe just make sure that AI doesn't format your hard drive. We really dig into safety, science, stewardship, and simplicity. In all of our work, we've discovered that doing the simple thing that works is often the best path forward. We're kind of on an exponential trajectory. Last year, I think, with the release of Claude 3, we really started to see that AI was able to help people to actually do useful work. You know, we figured that this is about the assist safely regime. This year, with the release of Claude 4, Claude has really taken a step up and is a collaborator. I'm really starting to feel that I'm working with Claude as opposed to leveraging Claude nowadays. And we're kind of envisioning in the next couple of years, we're going to get to the point where Claude is not only helping us, but is really in the driver's seat and is discovering things or at least discovering them faster than we would without the help. Quick bit about me. I'm a physicist by training. I did research in cosmology and black holes. I was a lecturer here at MIT from 2013 to 2019. I did a lot of stuff with 801, 802. I did a lot of work in MITx. If anybody used MITx for 801, 802, I probably wrote your PSETs. I took a brief sojourn to do some data science in finance for a few years, and early last year I joined Anthropic. I did some work on model architecture research, and I'm now doing research tooling and productivity. Basically, I discovered that it was better for me to make everybody else faster than for me to try and do my own research. How many people here are course 6? Most of you. Course 18? Few of you. Any course 8s? Yes, we have a physicist. Any grad students? No? Okay. Well, welcome. Very glad to be here. It's a pleasure to be back on campus, and I'm very excited to be giving this presentation. Can we let a few more people in the room? I guess if we shuffle along a bit. There's a few people just standing out. Okay. I want to give a really brief overview of how Claude works. This is actually very similar to how any of these LLM systems work, but I think having at least a basic understanding of the fundamentals is helpful if you're going to try and leverage these things. It helps you understand their foibles and just how to interact with them. The first concept that we need to talk about is tokens. A token is basically a way of representing text. We could represent text as individual characters, but that turns out not to be very efficient. We could try and represent text as words, but it turns out that there's just far too many words. It's most efficient for us to kind of take word fragments that we call a token. We have internally a tokenizer that can take text and turn it into a number, and also do the reverse process. Take a number, well, a series of numbers, and turn them back into text. Our tokenizer can treat every single ASCII character, and then also some common word parts that it finds are most efficient. The tokens are dominated by English, but are fully capable of representing any Unicode character. A good rule of thumb is that a token's about 3/4 of a word. Internally, Claude is processing one token at a time. It's kind of thinking in terms of tokens, but that's kind of an under the hood detail. It's not too important. For the purpose of hacking with Claude, I don't think you really need to think about tokens and tokenization so much, but it's important to understand the context of tokens for how many tokens are coming in, how many tokens are coming out, and how many tokens can I process in one go, otherwise known as our context length. Under the hood, Claude is a transformer model. Surprisingly enough, the AI model is not that complicated. It's really impressive that it works as well as it does. But for the purpose of hacking with it, I strongly encourage you to think of it as a black box. You put some text in. For some reason, we always represent transformers as going up. So text comes in the bottom, or tokenized text. And out the top, the other side comes probabilities, or strictly a probability distribution over what the next token should be. So, for example, the cat sat on the, what should the next word be, or the next token be? And so here we've got, hey, maybe the next token should, with probability 0.21 be mat, and probability 0.15 be table, and there's a very long tail of this distribution. Once you've got these tokens, probabilities, you need to decide, okay, I need to select one of these. We say we select mat, we put mat down the bottom, we push it through again, and we get the next set of probabilities for the next token. So we rinse and repeat. In order to actually generate text, we not only take these probability distributions, but we take a specific token for each token that we output. So we call this sampling. We basically randomly select one of these tokens that the probability says has some probability mass, and keep on going. The most important parameter when you're doing sampling is a thing that we call temperature. This has to do with the internals of how we actually draw the random number. The relevant scale is kind of 0 to 1. T equals 0 is fairly deterministic. It's not completely deterministic, but often you will see the same tokens come out if you do things repetitively. T equals 1 is reasonably creative and somewhat random. You're very unlikely to see the same tokens come out if you repeat it a few times over. If you start pushing your temperature too high, you'll eventually devolve into gibberish because the probability distribution becomes uniform over all tokens. The context window is a measure of how many tokens you can fit into the working memory in Claude. The context window is limited. You can't put an infinite amount of stuff in the working memory. Claude does not have that much memory. For most models, about 200,000 tokens is the limit. We do have a special model that can go up to 1 million. But for most applications, you probably want to stay well below these numbers. It becomes harder to reason over very, very long contexts. So often we try to stay within the 40 or 50,000 tokens just for best results. If you hit the end of this token, this context window limit, then you can't go any further. You basically have to start again or decide to chop some stuff out. But these are actually hard numbers. Most of the struggle with developing with these systems is managing the context window. So figuring out how to put the stuff that's most relevant in this context and leave off stuff that's less relevant so you've still got room to work with. Of course, if you had an infinite context window, you could put the entire world's knowledge in there, but an AI system would probably get really confused because that's just too much information overload for it to actually work with. Once we have a context window and a way to sample next tokens, how do we get a conversation out of this? It is kind of distressingly simple, what we've landed on. We've got a special token that we call human and a special token that we call assistant. And we basically say, human, here is the input prompt. Assistant, here is what the computer writes. And when the computer is done, it outputs the human token to say, hey, I'm done. Human should go next. And so you end up just concatenating these prompts together. You've got your human prompt, your assistant response. You want to continue the conversation, you put another human prompt, you get the next assistant response, and keep on going. So here's an example where we're talking about Pokemon, and we just keep on appending these turns together.
My name's Eduardo. From Stony Brook. For the tokens, I hear different things from my peers and what I see online about when you have these conversations and you concatenate the conversations together. That the token window is just the sum of the tokens, or it sort of sums up with your previous conversation.
So every time you send a new prompt that's got a whole lot of these, it's going to count the total tokens from everything in there, not just your latest one.
Got it. So as you go, it keeps on I guess growing faster the amount of tokens you're using, or
no, just linearly in the number of tokens you're providing.
Got it. Thank you.
Sorry, can I ask one more question? From what I understood, it was introduced that Cloud now can remember some details from the previous conversations. And how does it change the amount of tokens that's accessible in one chat?
That's a feature on Claude.ai,
yeah.
Where we're managing this context window to provide the chat interface. For the purpose of hacking, where you're sending text directly to the model, that doesn't exist. Okay, I want to talk a little bit about prompting. You probably heard the term prompt engineering. It is a little bit of a black art to give Claude instructions and get good results out. So I want to give you some guidelines for what makes a good prompt. Here's an example of what we found works well for a prompt structure. Start out by setting the role, setting the picture for here is who you are, here is the role you are playing, here's a high-level description of the task that you're trying to accomplish. Here is some information that we're adding on for you. So we'll inject some locations, some days, some user preferences. Here is detailed task instructions for what we actually want you to do. Whenever you're asking Claude to go and do something that's particularly something detailed, it's very helpful to give it some examples. The models learn from examples extremely effectively and can replicate how examples have been carried out. So if you're struggling with prompting, strongly recommend trying to give it some examples of what you'd like to see. Because of the way that the transformer architecture works, anything you put down the end will be fresher in the memory of Claude when it goes and generates things for you. So any critical instructions you've got, I recommend putting them at the end or even repeating them at the end.
Is something like capitalization, is that the way?
Not really. You can speak to Claude in Leet speak, and it pretty much understands what you're talking about.
Why is it that things later in the prompt are fresher to the transformer?
Well, when you go and read through a textbook, the last paragraph you read is probably closer to your mind. Basically, we've constructed these models to try and synthesize how we as humans think, and it kind of replicates that.
Is it any special science that can make Claude focus on some specific part?
Nope. You can capitalize and kind of yell at it, and it kind of understands when you're yelling at it. But yeah, I said it's a bit of a black art. You could also think of it as an experimental science. Try different things, see what works well for you. Recommend organizing your prompts. If you've got scattered stuff everywhere, it gets confused. So do organize things, strongly recommend putting things in XML tags. I mean, you can use whatever tagging system you like. We like XML because it's pretty token efficient. Claude understands XML pretty well, and it sets good delimiters that it's actually pretty good at working with. If you are trying to get something out the other end, if you're trying to have Claude generate something and you want this to be the answer, something that works very well is to say, please output your answer in an XML tag called this. So here, for example, we're saying, please present your itinerary within itinerary tags. So this lets Claude go and do some thinking and then say, okay, I'm good. Now I'm going to write my itinerary. Here's my itinerary tag. And it's very easy to pull out the stuff in those tags and to discard whatever other thinking Claude did in the meantime. Again, providing examples. A couple of places where this is really useful is if you really need it to have consistent formatting or specific jargon or specific standards, then giving an example is a great way of helping guide it so that it knows what exactly you're looking for. Often it is better to give an example than to try and describe in words what you're trying to do. Another trick that's useful, and you can only do in the API, is to pre-fill Claude's response. So you don't have to give it a human prompt, assistant, and then let it go. You can give it a human prompt, assistant. That's a really interesting question. Let me address this by doing these steps. Step 1, and then let it go. By pre-filling the information, you're kind of steering it in the direction you want it to go. So here's an example where if we're talking about this holiday itinerary, the standard response might say, here's a personalized blah, 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 and then the itinerary. If you just, this little preamble is not useful, then you can just say, okay, I'm going to prefix you with itinerary. And so it immediately starts by diving straight in. So this can be a useful technique for trying to get things out in a specific format as well.
So this will be put in the prompt.
Yes. I want to talk a little bit about dealing with hallucinations. You've probably heard that these models are pretty good at making shit up. And not only that, but it's very convincing. Sometimes it's helpful to explicitly tell Claude, if you're not sure, say, I don't know. It's okay to say you don't know. Sometimes you can say, well, only assess your confidence here and only output something that you're really confident in. You can have Claude think about something before answering. And sometimes it's helpful to tell Claude, go and look back at this thing I gave you. It could be quite long. Gather the relevant context so that it's fresh in your memory, and then synthesize an answer from that context. The worst hallucinations are going to be when you tell Claude to do something that is basically impossible or it doesn't have the context for, and it aims to please you. It can be pretty sycophantic at times. So try to avoid putting words in its mouth like, certainly, I will help you. The answer is like, well, you didn't give it time to think, so it's going to make something up that sounds plausible, and who knows. A few extra ideas for prompting. Sometimes you can take a long prompt and break it up into successive smaller prompts. You might find this works better. Avoid trying to do long decision trees. So you can have a prompt that says, if this, do this, if this, do this, and get a really nested tree out of this. That's a good way to get things confused. Would suggest breaking this up into smaller prompts and setting up a workflow as opposed to trying to do it all in one big prompt. Sometimes it's useful to have what we call an intent classifier. So a human puts in a thing and you say, hey, the human gave me this prompt. Can you please classify this as asking me to pull data, asking me to make a plot, asking me to return a table, or asking me to give an opinion? And once you get the classifier response saying this is what type of question it is, then you can give a specialized prompt saying, here is how we do plotting. Here is how to make a table. Go and do this. The user has asked, here's the user request. Here are all the tools that you need to go and actually pull this off. Prompts can get fairly long. Our Claude.ai prompt, for example, is over 20,000 tokens. Most of that is in examples for how we want it to behave, how we want it to use tools, and other stuff like that. I think it's actually public. If you Google search for it, you can probably find our system prompt. The other suggestion I have is don't try and do too much. If you want Claude to do X, then Y, then Z, then alpha, then omega, then scratch its head, then do a pirouette, and then give you the meaning of life, it's probably going to fall over. Generally speaking, trying to accomplish one thing within a prompt is reasonably safe. If you go to console.anthropic.com, we have a really neat tool called a prompt generator. You can tell it what you want it to do. We have a prompt to generate a prompt, quite literally. It's actually pretty good. I think it actually tries different things. It tests them out, gives you some sample responses, and it will help you refine to get a prompt that you can work with. Okay, tools. Tool use kind of burst onto the scene about 18 months ago and has become a foundational part of how we interact with models. At heart, Claude can't do anything other than generate more tokens. We've found it really useful to let Claude generate JSON that says, please take an action for me. Here's the details of the action I want you to take. Take this action, perform it, and give me back the response or the result. And you can put whatever you want on the other side of that action. We call that action a tool. Whatever is running the system will take back this response from Claude and should then go and figure out how to carry out this action, get the result from that action, and return the result to Claude as the next step of the conversation. And then Claude once again decides what tokens to generate next. And the important part here is that this allows Claude to interact with an environment.
So would you compare tools to functions and standard programming?
Yeah, basically.
Like the same thing just for integrating data?
Yeah, exactly. So Claude will give you back the arguments that you want to put into your function. And these functions can be, basically anything you want it to be. You can go and do data retrieval. You can do a web search. You can interact with an API. You can run some code. You can run a command line script. You can search the web. You can control your computer. It's pretty much whatever you can ask your computer to do, you can turn into a tool.
Doesn't allow such problems with sometimes it gives an answer not exactly in the format that you asked to give an answer in, that breaks your function because it doesn't receive it in the correct format.
Yeah, that does happen. It's relatively rare, like less than 5% of the time. Yeah. But it turns out that outputting perfectly structured JSON is actually kind of hard to do when you're just doing a stream of consciousness thing like these LLMs are doing.
Would you recommend to make some kind of checker that is also like Cloud or some another LLM, or how to?
What I would do if you are getting back a function call is to convert it to JSON. If it doesn't pass, then send a message back to Claude saying, hey, I tried to do this, but you gave me bad JSON. Can you please fix it and we'll try again? So here's an example of tool use. Say we've got an application over here, we've got Claude over here, and we want to give Claude access to some sort of tool. So let's give a prompt that says, how many shares of General Motors can I buy with $500? Claude, being an omniscient LLM, doesn't actually know the stock price at the moment. It probably knows what it was a year ago when we trained it, but no such luck today. So Claude will go and say, hey, I've got a get stock price tool. I'm going to return saying, hey, call get stock price tool for General Motors, please. It's then the app's responsibility to take this tool call and carry it out. So it can go to some stock market API it has access to, saying, get me the price, gets back the price from that API, and then it sends a new message to Claude or continues the conversation saying, here is the result of doing that tool call. And then Claude can use that information to submit its response. So here saying, you can buy about 11 shares.
So you never have to like manually type in the tool, like program the tool itself. You just ask it to call the tool.
So if you are in the chat interface,
Right.
then you ask Claude to do stuff, and if it figures out, hey, I've got a tool that can carry this out, it will go and do it automatically.
And then, but at the end of the day, you have to like call the tool.
The underlying application needs
Right.
to call the tool. Yeah.
Thank you.
Here's an example. Say you want to make a coding assistant. Let's say that you've got a code base that has 1 million lines of code. That's kind of overwhelming. It's not going to fit into the context window. How could you, Claude, think about interacting with this code base using some tools? Let's start by thinking about how humans do it. If you give me a 1 million line code base, I'm going to start by understanding, okay, where's the entry points? Where's the subsection of the code that I actually care about? What does that entry point go and do? What does it spin up? What does it invoke? Let's go and look at the key types, classes, data structures, gather the information, gather the context. If I'm looking for something specific, then I might search, just grep the code base for, some key strings and go from there. Basically, as humans, what we're doing is loading key parts of the content of this code base into our context, into our working memory, and then we try and do something with it. Maybe somebody's written a nice README file that gives us a summary of how things are structured and where things are and how we should go about working with them. This is basically what Claude's going to do as well, or this is how Claude likes to do it at least. Instead of trying to read everything, it's going to say, right, let me do some searching. I probably want a grep tool. I probably want a read tool that can go and read a file. I probably don't need a whole lot more than that. 2 tools and I can navigate a code base. That's pretty good. A few best practices for working with tools. Strongly recommend using a simple and accurate tool name and give it a detailed and well-formed description. You need to say explicitly what the tool is going to return, when it should be used, possibly when it should not be used. Generally, it's better to have a whole lot of simple tools that Claude can figure out how to put together than to have complex tools with various switches inside them. Claude will quite happily work with at least 100 tool definitions. I think we see over 200 before we start seeing degradation in tool quality. So feel free to go crazy with tools. Also, avoid having tools that overlap, that kind of do the same thing, because Claude will get confused about which one it should use. I want to talk briefly about the Model Context Protocol, or MCP, that you've probably heard of. Tools are kind of cool, but if you're developing an application, you need to go and not only tell Claude what tools it can use, but you need to be able to carry them out. And that can really be a pain. So the Model Context Protocol, or MCP, defines a protocol to stand up what we call an MCP server, which is basically a server that says, here is a list of tools that I can support, and here's an API to go and invoke those tools, and I will carry them out for you. So this is a really neat way of adding extra tools to Claude without having to actually code those tools up from scratch. There are MCP tools for lots of things nowadays. This is how Claude.ai interacts with the Google ecosystem, so Gmail and calendars and Google Docs and so on. Most productivity, online productivity tools have an MCP server associated with them now. Claude Desktop and Claude Code are both MCP clients. So you can hook these up to any MCP server that you want. And if you're going to be hacking with MCP, I strongly recommend just using Claude Desktop as the client to connect to your MCP server so that you can test out how it's working. Generally speaking, think of MCP as a tool server. Here is a place where some tools are defined, and I can run them for you too. There's kind of 3 options for where you want to run one of these. You can run it locally, which I recommend for hackathons, where basically you communicate via the terminal interface, which is really easy to do. You can also do a local web server, which is also fairly straightforward, and you can do a remote web server. Remote web servers are kind of a pain in the ass to get working though, so recommend avoiding that for a 24-hour hackathon. Here we go. Here's a quick video of MCP in action. This is from, I think over a year ago now, but you can see we've given Claude access to a GitHub tool, so it can go and be pointed at a GitHub repository and pull all the issues and think about which ones are most important. Next, it's saying, hey, find the most important issues in this repository and go and add them to my my Asana board so I can do some project management. And here's our Asana board, and we should soon find, yep, we're starting to see extra things get added as Claude creates the tasks in there. It's kind of magical that this works. You can think of something like Claude Desktop as an MCP client as being your command center for controlling an ecosystem of applications. I'm going to keep on going because we're a little behind time. I want to talk briefly about agents. What I've kind of talked about so far has been give Claude a prompt, get a response. Particularly in an API type setting, this is often what we call a one-shot prompt. You give it a prompt, you get the response, and that's it. In a chat setting, it's again, give it a prompt, get a response. Give it a bigger prompt, get the next response. We're still just going through a prompt response loop. If you want to do anything more complicated than that, you're basically going to want to use an agent. An agent has not only a loop going on between the human and the assistant, but also an environment that it can interact with through tool calls. Agents are basically what you are going to, the tool you're going to reach for if you want to do something in an autonomous fashion, where the system needs to figure out what it needs to do and to go and carry out that task. So anytime you want your system to have the autonomy to execute multi-step tasks, agents are going to be what you want. They're characterized by a lot of tool use. They can do planning and reasoning. They often do decision-making. They often try to implement something and then get feedback on their implementation and have an iterative cycle for improvement. And they're working towards accomplishing some goal. At heart, all they are really is tools that interact with an environment, a prompt that tells them what to do, and a loop that goes around in circles. They're actually pretty straightforward to set up. If you're going to play with agents, I encourage you to try and write your own. Keep in mind, though, you are limited by this context window. Agents can do a lot of tool use, can read a lot of files, can do a lot of web search, can put a lot of stuff into the context window, and can fill it up very, very quickly. So the tricky part of working with agents is managing that context window. Keep it simple. Don't try and do anything funky. Keeping things simple helps you iterate faster. From bitter experience, we have learned to keep it simple. At the same time, don't try and build agents for everything. Agents are not a drop-in replacement for every task that you're trying to do. They are not always the right tool for the job. Sometimes you want something simpler that will do what you want more easily. If you're trying to set up an agent to accomplish something, think about what your agent needs to do. Think about how you would go about doing it. Put yourselves in their context window. Break things down in the steps that you would need to do to actually go and accomplish this, including very basic steps. Like think about how you make a peanut butter jelly sandwich. You need to take the bread out of the bag first. You need to unscrew the lid on the peanut butter. You need to think about all of the little steps that you actually need to accomplish, because the agent is going to need to do all of those as well. I said keep it simple and don't always reach for an agent, especially for simpler tasks. Reach for a workflow if you've got something that can be done in one prompt type of thing. So request classification is just a one-shot prompt. Prompt routing, or determining which direction to go down a tree, again, is a workflow. One-shot results, decision trees, anything logically pre-programmed to go through a chain of actions that you can think of a priori is more of a workflow than actually needing an autonomous agentic loop. So don't overcomplicate it if you don't have to. Okay, at this stage, I want to give you some words of wisdom from things where I have, through bitter experience, failed. For programming, just use the SDK. There's a lot of things that wrap around the SDK, LangChain. I'm looking at you. Strongly recommend avoiding them. It's much better to work closer to the source and be in control of things and actually understand what it's doing. If you are working with MCP servers, strongly recommend building a local MCP server first. It's a lot easier to get that working, to get that stood up. Once you have a local MCP server working, then turning it into a local web host before turning it into a remote web host is definitely the way to go. From playing with these things, Claude is actually pretty good. If you give it good instructions, it will usually be able to handle the task that you give it. The tricky part often comes from setting up the connections, getting everything to work together, getting the scaffolding right. So think about that part as well as you're designing your system. And focus on demonstrating proof of concept behavior. If you're trying to get Claude to do something, see if you can do it in Claude.ai first. If you can't do it there, then you're probably not going to have much luck just doing it through the AI. On prompting, something I've really been interested to discover is how much context we have in our heads. When we ask a chatbot to go and do something, often we only give it a small fraction of the context that we actually have. And there's a lot of implicit context that we are actually thinking. And often we see, you ask Claude to do something, it gives you back a response. It's like, oh, yes, okay, you did that, but I really wanted you to do it this way, but sorry, I didn't tell you. So think about adding really clear and detailed instructions with exactly what you want it to do in a prompt. It's really helpful to think how a human would do things step by step to accomplish a task. These LLMs are basically going to go and do exactly the same thing. And trying to one-shot something complex can be really hard. Sometimes adding examples can help. Sometimes you do need to move to a more agentic workflow if you're trying to do something complex. For some human behavior, pick the right model. You're basically trying to balance three things in choosing a model to work with. The speed or latency associated with the response, so how quickly you get back the results, how much it costs, and how smart the model is. Opus is our smartest model. It's our most expensive model, and it's our slowest model. If Haiku, which is our smallest, fastest, cheapest model, also our dumbest model, is capable of doing something, then you probably want to only use Haiku. Generally speaking, Sonnet is a really good all-purpose model. The other thing that I think is really worth saying is use Claude to help build the thing you're trying to do, even if that thing is trying to use Claude. Claude is actually really good at using Claude. Okay, how am I doing on time? Got a few minutes. 5 minutes, okay. Quick tour through Claude Code. Claude Code is a local agent that runs on your computer in a terminal interface. It has a bunch of built-in tools for doing coding, and it is really good at it. It is excellent at understanding code. It's great at implementing features. It's really good at fixing unit tests that are broken. And if you're trying to understand something or find something in the code base, it's really good at finding that type of stuff as well. Often I will ask Claude Code to go and fix something or find something, and it goes down this rabbit's nest and it ends in a part of the code base that I'm like, no, surely you've gone off the rails. And 2 hours later, I realize, oh, it actually found exactly the place it needed to be. Claude is really good. I love letting Claude Code manipulate Git for me. I'll often tell it to look at the Git diff for the current dirty state, or to look at a specific commit to get context. It knows how to use command line tools. You know, it can go and interact with the GitHub command line tool to pull issues, to pull PRs, to to go and do things. It is extremely good at using Bash, much better than I am. And it is really good at refactoring code. I love asking Claude Code to write my commit messages because it writes much better commit messages than I do. A typical workflow for Claude Code is to start by saying, here's the context. I want you to go and read these files or read this location. Propose how to go and do something. Here's what I'm actually wanting you to do in this situation. Then go and implement it after we've back and forth on the implementation details. And once you've implemented something, let's test it in some way. And often we'll iterate through these, especially the implement and test part. Reward hacking is something you need to be a little bit careful about. Reward hacking is when a model has learned to maximize its training reward instead of doing what you want it to do. So if Claude gets rewarded for making your tests pass, one of the things it's learned to do is to swap out your nice unit test for assert true. Kind of sad, but just something to be aware of. It will often do silly things to avoid actually doing the right thing. It's trained on the internet. What do you expect? This often happens if you haven't given it enough context, if you've given it something ill-defined, or if you've given it something that's basically impossible. These models are not good about saying, I don't think this is possible. I think you're wrong here. They really like agreeing with you. You might have noticed. Vibe coding is this meme, I guess, where you basically say yes to everything that Claude suggests. Some people really view dimly on vibe coding, but I actually do it all the time. But it's useful to guide Claude as well. If you really just let it have its head, then you're not going to get something great out the other end. It's useful to give it some guide rails. I used to consider myself a software engineer. I'm not actually much of a software engineer anymore. I'm now a professional code architect and code reviewer. One of the things I'm often doing is asking Claude to check our work, to reflect back on what we've done and to make sure that it's actually doing what we want it to do. A few tricks for Claude Code. If you tell it to think or think harder, you'll enable extended reasoning mode, where it will actually think about what you've asked before going and doing it. This is a good way of spending more tokens to think about what you're trying to get done. You can drop images into Claude Code by using Control-V, which is kind of weird on a Mac, but it is actually Control-V. You can also just drag and drop an image on the terminal, or say, go and read this image file. And the other thing I do a lot of is to course correct. If Claude Code looks like it's doing something silly, I'll stop, press escape, and tell it to course correct. Or sometimes I can say, no, we've really gone in the wrong direction. I'm going to go back in our conversation and try a clearer prompt. We're out of time? Okay, this is my last slide. Write Claude MD files. Claude MD files are a good way of giving Claude Code a summary of what you're trying to do, how your code is organized, and where to go with it. Okay, fine. It wasn't my last slide. Okay. I'll leave this slide as the last one. This is a great resource for finding how to do stuff. Okay, thank you. I recommend going and finding us at table 13. We can give you the API credits there and let you sign up for other stuff. We are going to hang around.
As someone who used vibe coded basically my entire internship this summer, I was at Amazon. I basically used their equivalent of Cloud Code.
Yep.
And people in the beginning, I spent 3 weeks basically doing something that would look through logs and try to find it in a multi-million line code base. And some of the software engineers were like, "No, why are you doing this? It's not going to work." It ended up doing a better job than everyone who was responding on the tickets. Just a 2-page prompt. A workflow is just when you define it with instructions, right?
Yeah, you're basically saying, do this, get a response, figure out what to do next, do that, rather than letting it go in a loop and determine what it wants to do.
I don't want to be a little fanboy, but I appreciate the readable blog posts, research things on your guys' website. It's amazing. Yeah, I'll meet you guys at your.
Okay, thank you.
Cool question.